We're going to work on the problem 8.6.20, and we need to find the inverse matrix using row operation method. Our objective is to make it left side of this matrix as identity matrix. That is, this is 1, right? It's given like that, and we need to make 0 and 0. So second row is already 0. We need to do the third row as a 0. How? We have to use row 1. So we need to do R1 times negative 2, y negative 2, because by looking at this, the third row, we have a positive 2. So if you multiply negative 2 to first row and then add to R3 and put it into R3 back, so first row times negative 2, negative 2, 0, positive 2, and then negative 2, 0, 0. And when you copy down the third row, 2, negative 1, 3, 0, 0, 1, and then add 0, negative 1, 5, negative 2, 0, 1. So now the first column is 1, 0, 0, exactly what we wanted to have. Now our next step is make the second row, second column to be 1. So what we need to do, we need to divide whole row by negative 2. Then 0, 1, negative 1 over 2, 0, negative 1 over 2, and 0. Then we need to make a 0 above and the below. And fortunately, we already have 0 in the first row. So I'm going to just copy down. And then the third row, we see negative 1. So we need to use R2 times 1 plus R3, put it back to R3. We have a R2, 0, 1, negative 1 over 2, 0, negative 1 over 2, 0. And then R3, 0, negative 1, 5, negative 2, 0, 1. Add, we have a 0, 0. This is 10 over 2, so therefore 9 over 2, negative 2, negative 1 half, 1. So we have 0, 0, 9 over 2, negative 2, negative 1 over 2, 1. Okay, so next we want to make third row, third column to be 1. So going from here to here, we're going to multiply 2 over 9. Then 0, 0, 1, negative 4 over 9, 2 and 2, negative 1 over 9, and 2 over 9. And now, when I look at this first row, we have a negative 1. So what we need to do, we need to do R3 times 1 plus R1, put it back to R1. I3, 0, 0, 1, negative 4 over 9, negative 1 over 9, 2 over 9. And the first row, 1, 0, negative 1, 1, 0, 0. We have a 1, 0, 0. This is 9 over 9. So this is 5 over 9. So 1, 0, 0. 5 over 9, negative 1 over 9. I don't know why I stopped there, but we need to add this as well. So we have a 5 over 9, negative 1 over 9, 2 over 9. And now when we look at the second row, we have a negative 1 over 2. So R3 times 1 over 2 plus R2, put it back to R2. Again, these two numbers, the later two R, number R2, R2, They have to be the same. Okay? Here, R1 and R1, same. R3 and R3, same. You have to follow these steps, otherwise you're going to put some numbers back. So R3 times 1 over 2, we have 0, 0, 1 over 2, and we need to multiply 1 over 2 to negative 4 over 9, that is negative 2 over 9, and 1 over 2, negative 1 over 18, and then 1 over 9, and then R2, we have 0, 1, negative 1 over 2, 0, negative 1 over 2, and 0. We add 0, 1, 0, negative 2 over 9, and then negative 1 over 18 minus, I'm going to multiply top and bottom by 9. That is negative 10 over 18, which is negative 5 over 9, and then 1 over 9. So 0, 1, 0, negative 2 over 9, negative 5 over 9, 1 over 9. Now this is the inverse of the A. Now the A that was given as 1, 0, negative 1. Let's do it one more time. So copy this down using the technique that we use. And this technique, you have to use it when I ask you to find the inverse of matrix from the quiz or exam and the final. You have to do this. So first, we need to find the delta. How? Copy down top two rows here. Then we have a 1, 0, negative 1, 0, negative 2, 1. And diagonal way 1, 2, and 3. That is plus. So plus 3 times negative 2, negative 6. This is 0. This is 0. Opposite diagonal way, it's going to be all negative. 2 times 2 is 4, positive 4. This is negative 1, and this is 0. So our delta equals to negative 4 plus 1 minus 6. So negative 10 plus 1, negative 9. Now, we need to find A transpose. What I want you to do, I want you to put some stars around it. That's a nice star. And then circle around it. Or if you want to put some heart, that's fine. But you got to remember this. You have to take the transpose of matrix. So the transpose matrix is what? The column to row, row to column. So what I'm going to do, I'm going to circle the first row, and then we're going to put it into first column. That is 1, 0, negative 1, 0, negative 2, 1, 2, negative 1, and 3. And then what do you need to do? Copy down top two row, 1, 0, 2, 0, negative 2, negative 1. And then left two column, copy down 1, 0, 0, negative 2, negative 1, 1, 1, 0, 0, negative 2, then scratch out the first row, first column. So now our inverse matrix is 1 over delta, and the first AD minus BC, negative 6 minus minus 1 plus 1, AD minus BC, AD 1 minus 0, AD minus BC. So there's AD, which is 0, minus 2, and then AD minus BC right there. So 2AD2 minus 0 minus BC3 minus 2AD0 minus 1, and then the rest 0 minus plus 4, 0 minus 1, AD negative 2 minus 0. So that is 1 over 9. Our delta was 9, negative 5, 1, negative 2, 2, 5, negative 1, 4, 1. Our delta was minus 9. So minus 1 over 9. Sorry. Problem 8.6.50. There's a video solution available in the YouTube, but this is going to be something like this in your quiz and exam. I'll give you 3 equations and 3 unknowns, something like this, and then use inverse of matrix, find the solution. So when we do this, we need to have the coefficient that is 1, negative 1, 1, 2, 1, 2, 3, 2, negative 1 times x, y, z that is equal to 1, 2, negative 3. So that's how we set up the matrix first. And then in order to find x, y, and z, we need to divide both sides by this matrix, right? So in the matrix multiplication and division, if we had in front of x, y, and z, you need to put that into in front of 1, 2, and 3. And then you need to find the inverse matrix, just like what we did. And then you need to multiply 1, 2, and negative 3. This is 3 by 3, and this is 3 by 1. That makes sense. So it's 3 by 3. 3, 3 is the same. And the result is going to be 3 by 1. If you put this as in this side, this is 3 by 1, this is 3 by 3. Because the inner numbers are not the same, we cannot multiply. So make sure you put that inverse matrix in front of the right side of the equation 1, 2, and negative 3. Then find the inverse. So I want you to try, and if you got it right, good. If you get it wrong, make sure you check the video solution and go through that. So instead of doing this, we will do work on this. So this is slight modification from 8.6.50. So we have the coefficient of 1, negative 1, 1, 2, 1, 1, 3, 2, 2, and this is matrix A, and then x, y, and z equals negative 1, 3, and 8. Now we need to find the inverse matrix of the A. So the delta 1, negative 1, 1, 2, 1, 1, 3, 2, 2. Copy down top 2 rows. 1, negative 1, 1, 2, 1, 1, plus, and this is 2, this is 4, this is negative 3, and this side is some negative. 3 times 1 times 1, 3. This is 2. This is negative 4. So our delta equals negative 3, negative 2, positive 4, plus 2, plus 4, minus 3. That is positive 10, and then negative 1 is 8. So our delta equals to 2. Okay. Now A transpose. I'm going to put this A into the column. So 1, negative 1, 1, 2, 1, 1, 3, 2, 2. Copy down top 2 rows. 1, 2, 3, negative 1, 1, 2. First 2 column to here. 1, 2, negative 1, 1, 1, 1, 1, 2, negative 1, 1. Scratch out first row, first column, then our inverse matrix is 1 over delta, AD minus BC, 2 minus 2, 2 plus 2, negative 1, minus 1, 3 minus 4, 2 minus 3, 2 minus 1, 4 minus 3, 3 minus 2, 1 minus minus. And then that is 1 over delta, which is 2, and we have a 0, 4, negative 2, negative 1, negative 1, 1, 1, negative 5, positive. 8.7, Cramer's rule. When we have n linear equations, and we can use this Cramer's rule to find the solution. How? We can do, we need to find the delta, and then we need to find the delta 1 and delta 2 and delta dot dot dot. I mean, for us, we're gonna have up to 3 equations and 3 unknown. And so you need to find delta, delta 1, and delta 2, delta 3. So when do we use this Cramer's rule? I mean, sometimes you are given like a 5 equations and 5 unknown, but you are only interested in finding x values only or y values only, right? In the real application, sometimes we don't need all of those solutions. We just need only one. If that is the case, this Cramer's rule is really handy. So we know how to find the delta, right? Because we have A, B, C, D, E, F, G, H, I as the coefficient, and copy down top 2 row, A, B, C, D, E, F, and then we need to find delta this way, right? But for the delta 1, what we need to do, the first column, when we have the equations plus y plus z equals 2x plus 2y minus z equals 3x minus y plus z equals. On the right-hand side of this equality symbol, we're going to have capital A, B, C, like a 5, 6, 7, something like that. So the right-hand side, we're going to put here, and then just the rest, you just need to copy down from here. For delta 2, 2 is the second column. Therefore, we're going to keep the first column ADG, CFI, but in the middle, second column is going to be the capital A, B, and C, and so on. Okay, so let's do this. Our A is going to be 1, negative 1, 6, negative 1, 2, 4, 2, 3, negative 1. And then copy down top 2 row, 1, negative 1, 6, negative 1, 2, and 4, negative 2, negative 18, negative 8, 24, 12, and then positive 1. So our delta equal negative 24 minus 12 minus 1 minus 12 minus 18 minus 8, 36, negative 37 for these three. And then this is negative 26, 28. I'm sorry, this guy should be negative 1. This should be negative 1. So this should be positive 1. Should be 36, 35. So that is negative 63. That is a delta. So for delta 1, we're going to put this guy into the first column. Negative 2, 9, 1 over 2. Second column, third column, just copy down 2, 4, 3, -1. So that's the delta 1. And then copy down top two rows, -2, -1, 6, 9, 2, 4. That is positive 4. 18 times 9. This is 6. And this is -24. This is positive 9. So our delta 1, -6 plus 24 minus 9 plus 4 plus 162 minus 2. All the positive values, 28, so 190 minus 15, 16, 17, that is 173, the top one. So if you were asked to find the x only, the x that was the first variable when you set this matrix A, therefore delta 1 over delta, that'll give us x, and you can stop here. But if you are asked to find x, y, and z, then we need to go for delta 2 and delta 3. So delta 2, need to copy down that. So we have a 1, -1, 2. The third column is 6, 4, -1. In the second column, this is for delta 2. Second column is going to be -2, 9, 1 over 2. Copy down top two row, 1, -2, 6, -1, 9, and 4 diagonally. And these are the pluses. Plus, plus, plus. And then multiply them. -9, -3, -16. These are the negatives. 18 times 6, 108. And then this positive 2. And this is -2. So our delta 2 equals -108 minus 2 plus 2 minus 9 minus 3 minus 16. The 2 is -12, -16. That is -28. So -136. For delta 3, we have 1, -1, 2, -1, 2, 3, and then -2, 9, 1 over 2. So copy down top two rows here and the diagonal. This is 1, this is +6, -18, -8, 27, +1 over 2. So the delta 3 equals +8 minus 27 minus 1 over 2 plus 1 plus 6 minus 18. So the +14 minus, actually 15 minus 45 minus 1 over 2, -30 minus 1 over 2, 61 over 2. I think for this Cramer's rule, one problem should be enough, right? And there are more problems you can check on the homework and also video solutions. And you can come up with your own problem. You can have these three equations and three unknown. And use your calculator, get the solution, and try all these three different methods. See whether you can get the same answer or not. If it's not, then you need to practice a little bit more. Make sense? The last section from chapter 8 has eigenvalue problem. So this is going to be a little bit hard, meaning it's going to be good candidate for the exam and the final exam. So eigenvalue problem. It's open to, sometimes we need to get the some matrix such that we can multiply that very specific matrix K into matrix A, and we're going to get the common multiple of the lambda. you know, and this lambda is what we call eigenvalue, and they are using lambda to create the vectors. That's the eigenvector. You need to have this guy and this guy. In the cheat sheet or in a note, when you deal with this eigenvalue problem, you need to go through these steps. Step one, we need to find the determinant of A minus lambda I equals to 0, and then find the eigenvalues from here. And then second equation you need to do is the matrix A minus lambda I bar 0, just like a section 8.2. And then from there, we can find the eigenvector. So let's do this. So the system, the matrix, is given as A equals 3, 4, negative 1, 7. First thing we want to do, we want to do determinant of A minus lambda I, and we're going to let that equal to 0. So we have A, 3, 4, negative 1, 7 minus lambda I. What is I? Identity matrix 1, 0, 0, 1 equals to 0. And this whole thing of the determinant. That means determinant of when we have the lambda time identity matrix, lambda times 1 is lambda, lambda times 0 is a 0. So basically this diagonal, we have a lambda right there. So 3 minus lambda in the diagonal way, 7 minus lambda, right? Because we're going to multiply lambda in the diagonal. So whatever we have a value in the diagonal minus lambda, and the rest, you just need to copy down. And then determinant of this matrix, AD 3 minus lambda, 7 minus lambda, minus BC minus BC 4 times negative 1, negative 4. So it's going to be positive 4. And that equals to 0. Let's FOIL it. 21 negative 10 lambda plus lambda squared plus 4 equals to 0. So from here, we have a lambda squared minus 10 lambda plus 25 equals to 0. And at this point, you can use your calculator. Again, you can use apps and option number 9 and polynomial root finder. You should know how to use your calculator to find the roots of any polynomial. Type the coefficients. You should be able to get lambda equals to 5, lambda equals to 5. This is basically lambda minus 5 squared equals to 0. And these lambda 1, lambda 2, those are the eigenvalues. Very good. Since we have two lambdas, you need to give me two eigenvectors. It doesn't matter they are the same or not, so you need to give me same number of lambdas. So since the eigenvalues problem, we have to use the determinant. That means either you're going to have a 2 by 2 matrix just like this, or most likely you're going to have a 3 by 3. We'll have that another example. So now, once you have lambdas, second step is going to be use for lambda 1 equals to 5. We need to do A 3, 4, negative 1, 7 minus lambda times I 1, 0, 0, 1 and bar 0. We need to create this matrix, and that is 3 minus 5. So I'm going to put it 5 here. So 3 minus 5, negative 2, 7 minus 5, 2, and then the rest 4 and negative 1, and then bar 0, 0. Okay, we're not done yet. For this step, what it says here, we need to apply Gauss-Jordan elimination technique. Just like 8.2, what do we do in the Gaussian elimination method? We need to make this guy 1 and this guy for 0, right? So to make this to 1, I can multiply negative 1 over 2. Then we have 1, negative 2, 0. To below 0, we need to use R1. R1 times 1 plus R2, put it back to R2, R1, 1, negative 2, 0, and R2, negative 1, 2, 0. When you add 0, 0, 0. So for eigenvalue problem, you're gonna have one or more row of zero. You end up getting one or more of zero. Take a note on that. If it's not, you did something wrong. One or more rows of zero. So when we deal with this 2 by 2 matrix, always we're gonna have a one row of zero. When we have the 3 by 3 matrix to find the eigenvalue problem, one or two rows of zeros. And once you get to this, now we cannot do any further because this is 1, and this one is 0. So we are done. Now, the first column, I'm going to call it lowercase k1, second column, lowercase k2. So based on this, you can say k1 times 1, which is k1, and plus k2 times negative 2 k2 equals this side 0. So based on this Gauss-Jordan elimination technique, we end up getting the relationship between K1 and K2. And if you have a 3 by 3 matrix, we're going to have a relationship between K1, K2, and K3. We won't be able to find exact value except for 0. We're going to have a relationship something like this. That means K1 equals to 2K2. So our capital bold base of the vector, eigenvector for 1, K1 equals, we have to use this. So we're going to let any value as a K2. K2, if you let K2 equals to 1, and then K1 is going to be 2. As I said, we have a 2 eigenvalues. Therefore, you need to give me 2. So the second eigenvalue is again lambda equals to 5, which is the same. So we end up getting the same relationship. So big K2 is going to be, I'm going to let this time K2 equals 5. Then K1 equals to 10. Hey, Dr. Kim, I want to let K2 equals to a negative number. Fine with that. If you let K2 equals to negative 1/2, then K1 equals to negative 1.